Hello everyone, I'm Mendelstein and this is the 6th development week of my massively multiplayer online strategy game. Today I've continued with the optimizations and implemented rule number 4, Frustum Culling. Frustum Culling is a simple technique which discards all non-visible objects so that only the visible ones are rendered. When you look at the terrain, you can see that all terrain blocks are enclosed by colored bounding boxes. Now every time when the scene is rendered, only the terrain and the water inside visible bounding boxes are rendered. This is achieved by checking if the bounding boxes overlap with the frustum of the camera. The frustum represents the current visible region of the scene. Currently, the number of the visible objects are displayed in the console. Today I actually wanted to implement rule number 3, but then discarded the idea because it would only optimize the memory usage, what is not that important right now. Instead I optimized the loading process of the terrain blocks. As you can see here, the loading process needs a lot of time, leading to the sequential appearing of the terrain blocks. So I analyzed the process and it turned out that the cause is the loading of the color map texture. Discarding the color map texture leads to a faster loading process, but also to a colorless world. There are two solutions to this problem. The first one is that I could discard the color map texture completely and calculate the pixel color inside the fragment shader based on the height and slope of the terrain instead. The second one is that I could load a terrain block without a color map at first, but then asynchronously load the color map and then add it to the terrain block. I will use the second approach because it is much easier to implement, but in the future I might implement the first one because it is more memory efficient and the correct pixel colors are immediately rendered. I've been working for 2 days on a level of detail system for the terrain and the water. Level of detail, or LOD for short, means that, for example, a terrain block has multiple meshes with different resolutions. If the terrain is far away, no details are needed, and for the sake of efficiency, meshes with lower resolutions are used. But if the terrain is near, then I want to display details, and therefore the high resolution mesh is used. If you look at the squares of the meshes, you can see that they get smaller the closer the camera gets, and larger the further the camera gets. And that was it for this week. Don't forget to like and subscribe. See you next week.